For countless generations, humanity has looked up at the night sky, filled with wonder and curiosity about the mysteries of the universe. In the 20th century, scientists introduced a groundbreaking idea known as the Big Bang Theory, which aimed to explain the origin, development, and expansion of the cosmos. While the theory provided answers to many critical questions, recent discoveries have only deepened the mystery. In 2023, NASA's James Webb Space Telescope made a startling observation. It detected a celestial object that appeared to be older than the universe itself. This unexpected finding left scientists puzzled, as it challenged the very timeline of cosmic history. How could a star exist longer than the universe in which it resides? This paradox has sparked debates about our current understanding of the cosmos, and raised the possibility that a new model might be needed to explain these anomalies. One such celestial object is located about 200 light-years away, near the constellation Libra. The star, known as HD 140283, also nicknamed Methuselah after the biblical figure who lived 969 years, has captured scientific interest for its extraordinary characteristics. With an impressive velocity of over 44,000 kilometers per hour, it hints at a dramatic past. Roughly 1 billion years ago, during the formation of the Milky Way, our galaxy is believed to have merged with a smaller dwarf galaxy, possibly Methuselah's original home. However, it's not the star's speed that astonishes scientists the most. It's its age. Methuselah is considered one of the oldest stars ever observed. Early estimates suggested it could be around 16 billion years old, but more refined calculations place its age at approximately 14.46 billion years, with a margin of error of about 800 million years. This is particularly perplexing when contrasted with the widely accepted age of the universe, which is around 13.8 billion years, based on observations of the cosmic microwave background radiation. How can a star be older than the universe itself? This contradiction has led astronomers to question the accuracy of our age-dating methods and even reconsider the true age of the universe. Determining the age of stars is no simple task. Unlike humans, stars remain stable in size and temperature for billions of years, making age estimation extremely difficult. Scientists study subtle changes in a star's brightness and color over time and compare these traits to theoretical models of stellar evolution. One useful technique, gyrochronology, involves measuring a star's rotation speed, since stars slow down as they age, much like a spinning wheel losing momentum. Methuselah, as far as current science can tell, truly is an ancient relic of the cosmos. But instead of assuming it predates the universe, some researchers suggest another possibility. What if the universe itself is actually older than we thought? To understand the immensity of cosmic time, imagine compressing the entire 13.8 billion year history of the universe into a single calendar year. In this cosmic calendar, the Big Bang would occur on January 1st. Earth would form sometime in late December, and recorded human history would fill only the final few seconds of December 31st. Traditionally, scientists determine the age of the universe by observing the light from distant stars and galaxies, some of which formed hundreds of millions of years after the Big Bang. As the universe expands, the light from these objects shifts toward the red end of the spectrum, a phenomenon known as redshift. By analyzing this redshift and measuring cosmic distances, astronomers have arrived at the 13.8 billion year estimate. However, recent research from the University of Ottawa suggests that the universe could be far older, possibly 26.7 billion years. Physicist Professor Rajendra Gupta has proposed a new theory that challenges our understanding of redshift. By combining Swiss astronomer Fritz Zwicky's 1929 tired light hypothesis, which posits that photons lose energy over time, with newer ideas, Gupta suggests that redshift might not solely result from universal expansion. Instead, it could be a hybrid effect involving both cosmic expansion and energy loss during light's journey across vast distances. If this reinterpretation holds true, it would significantly extend the estimated age of the universe and potentially resolve long-standing cosmological puzzles, including those raised by NASA's recent observations. Gupta's theory also incorporates the idea of a changing interaction constant, a concept originally introduced by physicist Paul Dirac, which suggests that the fundamental interactions of particles may have evolved over time. It's important to remember that scientific estimates of the universe's age have changed over the years. In the 1920s, Edwin Hubble's early calculations suggested the universe was just 2 billion years old. As our methods and data have improved, our estimates have become more accurate, often doubling or refining earlier values. No matter whether we think of human history as occupying 10 seconds or 5 seconds in this cosmic timeline, one thing remains clear: the universe is an ancient, awe-inspiring place. Its continued expansion, along with new discoveries, keeps reshaping our understanding of its origins and structure. Even within our own galaxy, the Milky Way, recent findings raise intriguing questions. Observations indicate that stars in the galaxy's outer regions move significantly slower than expected. This could suggest one of two possibilities. Either our galaxy contains far less dark matter than previously assumed, or our understanding of dark matter's properties is fundamentally flawed. These insights come from data gathered by the European Space Agency's Gaia satellite, which has mapped the positions and motions of nearly 2 billion stars in our galaxy. Such precise data has led astronomers to reevaluate how stars behave in the outskirts of the Milky Way. The velocity of these stars serves as a key indicator of galactic mass, since gravitational pull, which governs their movement, is directly tied to how much matter the galaxy contains. Based on Gaia's findings, scientists now estimate the total mass of the Milky Way, including stars, gas, dust, and dark matter, to be about 200,000 billion times the mass of our Sun, roughly 5 times less than earlier estimates. Interestingly, this shift isn't because the visible material has vanished. Instead, it may imply that dark matter is less abundant than we thought. Alternatively, it could mean there are still flaws or uncertainties in our methods of measuring galactic mass and interpreting the data. In any case, the story of the universe is far from fully written. As telescopes become more powerful and our models more precise, new discoveries will continue to reshape what we know, or think we know, about the cosmos. If you're fascinated by these mysteries, make sure to like this video, subscribe to our channel, and turn on the notification bell so you never miss an update. We'll see you in the next one.